Given the optimum solution of headway, we can calculate the optimum total cost under the optimum solution. So for the case 1, we plug in the expression of the optimum headway. Then we can get, for the second case, we can have a similar expression. So the value of total cost depends on if the headway is bounded or not. So this expression is analytical. So that means we can directly observe the structure of how different input parameters affect the objective value, which is total cost. Let's take CF as an example. So that means if CF changes, let's see how would it affect the total cost. So you can see we have two cases, and then when CF is very small, when the fixed cost is very small, we can see the first case is effective because in this case, the optimum headway should be small. And then when CF is large, fixed cost is very large, the optimum headway should be large, and then it should be bounded by the capacity. So the second case is effective. And then from the analytical expression, we can observe that in the first case, as CF increases, we can expect that the total cost increases with a square root order. So that means the increasing trend should be this way. And then if we observe the second case, when CF becomes very large, the order should be linear. So the increasing trend should be linear. So if we combine these two cases, we can expect that as the fixed cost increases from very small value to very large value, the total cost per item should increase first in a square root order and then in linear order. So let's use Colab to verify our observation. So first, we'll define the total cost under the optimum headway. So this is a wrap-up of all the formulas we have. Optimum headway based on the minimum of two cases. And then we have our expression for the total cost. So to verify how the fixed cost changes would affect the total cost, we fix all the other parameters the same. And then we will slightly change the fixed cost from 1 to 800. Note that we need to start from a positive number. That's why I put I plus 1 here. So if the fixed cost is 0, there will be issues. So to check how the cost changes for different fixed costs, we just create a list. Then we put the variation of the fixed cost and then store all the total cost in a list and then plot it. To show how the two cases affect our observations, we compare different capacity. So let's see the results. Definitely we find the trend connecting two cases. As we just observed from the analytical expression, the trend should be first in a square root order and then in a linear order. So the first point, when the fixed cost increases to a certain value, around 100. So if the capacity of the truck is 50, then it will reach the capacity. So the trend of the total cost switches between the square root order increases to the linear order increases. And then if we keep increasing the fixed cost around 400, the capacity value 100 is reached, and then the trend switches between the square root increase to the linear increase. And as you can see, which is very intuitive, when the capacity increases, this is 50, this is 100, this is 150. As the capacity increases, the total cost decreases because it will be bounded later as the cost increases. So this verifies our expression